In this video lecture, we're going to go fairly quickly through the notion of cascade composition. When you try to compose finite state machines, you have multiple ways to connect them together. Why do you want to do that? Because it's actually much easier to deal with smaller, simpler building blocks to create a bigger, more complex one than dealing with a complete system to model all at once. So you have this notion of side-by-side composition, cascade composition, or feedback composition. Let's review actually only the first two. Side-by-side composition, you have two finite state machines with independent inputs and outputs. Why do you want to do that? Because you want to specify a common reaction model, or actually specify how they behave together one to the other. They can be working together in locksteps, fully synchronous, so it will work for a clock, or they will be both reacting to the complete set of inputs before evaluating the transitions. Or they can be fully independent with an asynchronous model, and every single finite state machine will behave differently. Cascade composition, it means that one finite state machine feeds a second one. In that particular case again, how will they react? If it's an event trigger, it's likely that finite state machine B is only going to react to the output transitions on A. If they are time triggered, they will both react to the same clock. To give you an example of this cascade composition, one could look at our example of the pedestrian crossing and the addition of a pedestrian light. In this particular case, I will let you go through this example, but the green and red light are going to be linked to the pedestrian crossing finite state machine to understand when to turn on and off. So we have a fully independent finite state machine though, with some inputs, sig r and ped g and ped r, and some variables. But then you will be able to connect them together with our previous example and cascading sig r into the output of sig r, the first one, into sig r of the second one.